In April of 2020, the Hubble Space Telescope celebrated its 30th birthday, which marked an important anniversary in the fields of astronomy and research. This anniversary is an exciting time to reflect on where astronomy is headed in the years to come, because the mission is often celebrated for the breathtaking images it has returned from orbit. However, the telescope has also altered the course of space research, which makes this anniversary an even more exciting occasion. On April 24, 1990, the Hubble Space Telescope, which was jointly developed by NASA and the European Space Agency, ESA, was placed into orbit by the Space Shuttle Discovery. The spherical aberration of the Hubble telescope was the root of a great deal of trouble during the early years of the observatory's operation. As a result of this optical defect, the very first servicing mission for the Hubble Space Telescope included the addition of a second optical component. Since that time, data and images have been beamed back by the People's Telescope, which have altered both scientific knowledge and the popular vision of the cosmos. This has provided a new perspective and surpassed all expectations. Let's take a deep dive into the most groundbreaking discoveries made possible by the Hubble telescope so we can commemorate its 30th birthday this year. Because of the astounding number of galaxies that were captured in a single image by the Hubble Deep Fields, which were released during the early years of the telescope's operation, the scientific community and the general public were mesmerized by the images. These are extended observations of a relatively small region of the sky, with the goal being to gather sufficient light from far-away objects to make out their shapes. By analyzing the hundreds of galaxies that were captured in these deep field images, astronomers were able to learn more about the early universe. Some of the galaxies that were captured in these images were the most distant primordial galaxies ever seen. One of Hubble's primary objectives from the beginning was to determine the Hubble constant, which is a measure of the rate at which the universe is expanding. This number is essential for determining the age, magnitude, and destiny of the universe. Before the launch of Hubble, scientists had a range of estimates for the age of the universe, but the most accurate number they could come up with was between 10 and 20 billion years. Recent research has shown that astronomers have been able to refine their estimates of the current expansion rate of the universe by utilizing data and observations obtained from the Hubble Space Telescope. The age of the universe has been estimated by scientists to be 13.8 billion years old. This was accomplished by using Hubble's updated distance estimates. The measurements that Edwin Hubble took are credited with being the basis for the now famous conclusion that the expansion of the universe is accelerating rather than remaining unchanged. Scientists are in agreement that the acceleration of cosmic events is due to dark energy, which they estimate to account for approximately 70% of the universe. Hubble has been at the forefront of research into both dark matter and dark energy since the field's inception. The well-known Space Telescope has been of great assistance to researchers studying black holes and supermassive black holes. The spectroscopic observations made by Hubble have shown that stars in the centers of galaxies circle around one another very quickly and in a very tight pattern. Only the extremely high gravitational field produced by a supermassive black hole could account for such an odd pattern of behavior. The Hubble Space Telescope provided the very first undeniable proof of their existence. It is currently believed that every galaxy contains a central black hole at its very core. Because Hubble was able to make such precise observations of objects located within our own solar system, planetary science has made significant strides forward. For example, in 1994, Hubble saw a comet collide with Jupiter's moon Io. But auroras have also been observed by it on Saturn and Uranus, in addition to a number of other planets in our solar system. The data collected from Hippocamp, which orbits Neptune, were used to gain a better understanding of the planet's origins. Hippocamp is the moon with the smallest known diameter. Observations made by Hubble in 2013 of Europa, an icy moon orbiting Jupiter, near the moon's south pole, revealed the presence of water vapor erupting from the surface of the moon. Additionally, Hubble has looked for evidence of civilizations beyond our solar system. In the year 2018, Hubble provided astronomers with their clearest and best observation to date of the interstellar visitor comet 2I/Borisov, which is thought to have come from another planetary system somewhere else in our galaxy. In the year 2019, Hubble provided astronomers with their clearest and best observation to date of Oumuamua, the first interstellar object found in our solar system. The Hubble Space Telescope has been largely responsible for the significant leaps forward that have been made in our understanding of distant worlds known as exoplanets. Although the analysis of a planet's atmosphere was not one of the telescope's primary functions when it was first invented, it is now possible thanks to the distinctive chemical imprint that the telescope leaves on starlight. The fact that we only had evidence of 9, now 8, of the planets in our own solar system at the time that the telescope was launched makes this phenomenon even more incredible. In his research on the Orion Nebula, Hubble made the startling discovery that at least half of the stars in the region were encircled by whirling disks of gas and dust. These disks provided the raw materials that were necessary for the formation of planets. Hubble's discovery was a revelation. In 2016, Hubble was able to conduct the first ever study of a super-Earth that was located 40 light-years away and found to have a dry atmosphere. In 2019, astronomers used the data from the telescope to make the astounding discovery that water vapor was present in the atmosphere of a super-Earth that was located in the habitable zone. This was a significant step forward in the search for habitable exoplanets. K2-18b, an exoplanet 8 times the mass of Earth, was the only planet known to circle a star outside the solar system with water and temperatures that potentially support life at the time that it was discovered. It is now more likely than ever before that there is life elsewhere in the universe thanks to the findings of the Hubble Space Telescope, which showed that planets are forming around many more stars than was previously thought. The photograph titled Tapestry of Flaming Starbirths depicts one of the most striking examples of the numerous chaotic star nurseries that have been discovered by the telescope over the course of its 30-year career. The enormous nebulas NGC 2014 and NGC 2020 can be seen in the photograph. Both of these nebulas are found in the Large Magellanic Cloud, which is a satellite galaxy of the Milky Way and is approximately 163,000 light-years away. Both the National Aeronautics and Space Administration (NASA) and the European Space Agency (ESA) worked together to complete the Hubble Space Telescope, making it not only an example of engineering and research but also of international cooperation (ESA). As long as all of its parts continue to function properly and it continues to be of use to the scientific community, we are all excited to see what the next 30 years have in store for the Hubble Space Telescope, which recently celebrated its 30th anniversary.